Hello, Year 11. We're picking up Booklet F. This is part 2. The plan was to get this far in part 1, but we didn't. We made it to the end of quadratic graphs and cubic graphs. So we're picking up here on straight line graphs, inequality graphs. We'll also try in this one maybe the trapezium rule. And time allowing, we'll have a look at some transformations of graphs and leave these last few till the part 3 of this video. So I've numbered my pages starting with page 1 being this page. Therefore where I'm at now is page 9, which is here. So we're having a look at straight lines which are of the form y equals mx plus c. So things like y equals 3x minus 2 or minus 3x plus 2 or whatever we're given. The number before the x, which is the m value, that will tell you the gradient of the graph. So in this case here, my gradient would be minus 3. Okay, and then the c value, the loose number as it were, we talked about this in part 1, that's the y-intercept where this line will cut through the y-axis. So what I'd be expecting of this graph is a negative gradient but a positive y-intercept, a little bit like this line here. Okay, this line has a negative gradient, the line is coming down as opposed to up. Okay, but cuts y at a positive value here. Now we don't know what this value is, but this is enough information for us to identify which of these has the potential to be this line. So again, this doesn't photocopy brilliantly. The first equation, should say minus x minus 2. The number before the x being minus 1, so a negative gradient, but also a negative y-intercept, so it can't be you. This one is saying minus x plus 2, okay? So a negative gradient with a positive y-intercept. That's suitable for this. Let's just go on and say why the others aren't suitable. This one, positive x, positive y-intercept. So the problem here is the positive gradient, which is not what we wanted, so not suitable. This positive gradient, negative y-intercept, neither of those are suitable. And this has got the negative gradient, that's minus x, but doesn't have anything here suggesting that the y-intercept is 0, which it's not. Okay, so it can't be you. The next type of question here asks us which one of these coordinates could possibly be on the line 2y equals 3x plus 4. Every coordinate is split into an x coordinate and a y coordinate. Okay, so all these have an x coordinate and y coordinate, and all we've got to do is take the x coordinate and the y coordinate and slot them in to this equation and see which one works. Now I've only done 2 examples in the exam, you'd have to do them all. So I've picked out this one where the x coordinate is minus 2 and the y coordinate is 5. And based on that, I'd be saying that 2 lots of y, or 2 lots of 5, is equal to 3 lots of x, or 3 lots of minus 2, plus 4. So 2 lots of 5 is 10. 3 lots of minus 2 is minus 6, but add 4 is minus 2. So that sum does not work, that does not balance. Then we compare it with what the correct answer is. If y is 5 and x is actually 2, we end up with 2 lots of 5 being equal to 3 lots of 2 plus 4. So 10 equals 10, which it does. And that's the correct coordinate. That's the values that actually make this equation balance or the sum work. Okay, to the bottom. What about actually working out a gradient if we're given a line? In order to work out a gradient, we're going to need to connect 2 nice points with a little triangle like this. Okay, they're the 2 I've gone for. And we're looking for, which you can see here hopefully, the gradient m is equal to the rise, how far up, divided by the run, how far across. In this case, going from there to there, I've gone up 2 and across 3. So my gradient is 2 over 3. Once I get the numerical size of the gradient, then I have to look, okay, but is it a positive gradient or a negative? In this case, the line is going up. So this is a positive gradient, so it's positive 2/3 as opposed to negative 2/3, which I've circled there. Another example of that. Okay, they've drawn this line for us, and part I says write down the gradient of the above line. Again, I've picked out 2 nice points. Your triangle can connect any nice points. It doesn't matter where. It can be a bigger triangle than that. As long as we stick to rise over run. Rise over run. In this case, in the time this has gone up 2, we've gone across 1. A rise of 2, a run of 1. Gradient, rise over run, 2 divided by 1 is 2. The other important bit of information here is the y-intercept, which is 4, which allows me to write the equation of the line using y equals mx plus c, but instead of m, I'm writing the gradient 2, and instead of c, I'm writing the y-intercept of 4. You can see those 2 values. There. Okay, and finally, on this double page, in order for 2 lines to be parallel, their gradients need to be the same, and I've done a little sketch to show why that's the case. These 2 lines have the same gradient and therefore are parallel. What is different about these 2 lines though is the y-intercepts. So you can have different y-intercepts, but as long as your gradients are equal, 2 lines are parallel. Now, normally the gradient is the number before the x, so in this case it would be 5, and in this case it would be 10, suggesting they're not parallel. However, this is not quite in the form y equals mx plus c yet, because this is 2y equals this, and this is 4y equals this. So in order to make it y equals, I need to divide both those values by 2, which is what I've done here. And to make this y equals, I need to divide both those values by 4, which is what I've done here. Suggesting now that the gradient of this line is 2.5, and the gradient of this line is 2.5. Yes, my y-intercepts are different, but that doesn't matter. Same gradients, different y-intercepts, therefore these 2 lines are parallel. On we go. Bit of a mixture of everything on this page now, okay? Again, 3y equals 2x plus 6. I don't want that, I want y equals, so I've divided both those by 3. Obviously 2 doesn't divide by 3, so I've just written it as 2/3. However, 6 does divide by 3. 6 divided by 3 is 2. So I've kind of rearranged that there so it's y equals. So this line has a gradient of 2/3 and a y-intercept of 2. I'm then asked to find another straight line that is parallel. I don't care about the 2. What I care about if it's going to be parallel is equal gradient to this. So where have I got a gradient of 2/3? And here, again, if I take that 3 over and divide that 2 by 3, there's my same gradient. I've started writing some of the other gradients in, but you hopefully can see that. I wouldn't get too worried about perpendicular lines, okay? It's far less likely to be asked than some of the stuff we've done already, okay? But to be perpendicular means to cut at 90 degrees. So if this line has a positive gradient, this line would have a negative gradient. So the gradient of the line given in the question here is 5, alright? But in order to be perpendicular, I'm looking for something with a negative gradient. Now, the other thing that I'm going to say, but again, I wouldn't worry too much about this, but if you understand it, great, okay? In order to be perpendicular, the gradient needs to be the negative reciprocal. So it's not as easy as just putting a minus and looking for minus 5. It would be minus, and the reciprocal of 5 is 1 over 5. So which one of these lines has a gradient of minus 1 over 5? And even though it's not written that way, it's the last one, okay? Think of that as minus 1x over 5, so you can see then the minus 1 over 5. So he is the perpendicular line. A couple more. Again, what's the gradient of this line? Well, can't really tell you until we divide through by 6. We want y equals, so 3 over 6 is the same as a half. Here again, what is the y-intercept of this line? I can't tell you it until I've got y equals, so I've moved the plus 3 and the 5x over, and that has identified the y-intercept for me. And the last one, a variation on what we've done before. Again, I'm looking at x and y coordinates, but I need to find a coordinate that's on both of these lines. So a coordinate where the x coordinate add the y coordinate is 7, but the x coordinate take away the y coordinate is 3. Now, on initial inspection, I spotted that this one here and this one here, okay, have an x and y coordinate that add up to 7. 4 plus 3 equals 7. 5 plus 2 equals 7. However, I also need, so both these are on that line. However, I also need them to be on this line where the x coordinate take away the y coordinate is 3. 4 take away 3 is 1. No good to me. 5 take away 2 is 3. So that one there ticks both boxes. So that's the answer. Okay, something a bit new. We have done some in class. You should be familiar with some of these inequality graphs, which we'll come on to in a second. But let's solve some equations with inequalities where we actually have to form the equation. These haven't been asked for a couple of years. They put a couple of them in 2016, 2017, but we haven't seen them since. But I think they're pretty simple as long as we kind of read what's going on. So the first one, Rashid owned N sheep. So under Rashid, I'm going to write N. Ivion had exactly 4 times as many sheep as Rashid. Well, if Rashid's got N and he's got 4 times as many, Ivion has 4N. Rashid buys 17 extra sheep. So whatever he started with, which was N, we can now add 17 to it. Ivion sells 8 of his sheep. So he had 4 times as many, he had 4N, but now he sold 8. So we're going to take 8 away. Then comes the inequality bit. Ivion still has more sheep than Rashid. Okay? Form an inequality in terms of N. If he has got more than him, okay, okay, I don't want to get too kind of year 6 about this, but I think of the you're almost eating the bigger number. Okay, if Ivion's got more, the open side is on Ivion. All right. Now the next bit says solve. Now we've done loads of solving equations in our algebra, our last algebra booklet, booklet E. But how are we going to solve this? I've got to collect my n's one side, my numbers the other. If I move the 4n over here, I'd end up with n minus 4n. Don't like that. That would leave me with negative amounts of n's. So leave the 17, bring the minus 8 over with it to be plus 8 this side. Sorry, I'm going to write this on a line below to give me room. Leave the 4n there and bring this n over with the n's as a minus n. You end up with 25 and 4n take away n is 3n. 3 times n, the opposite of times in by 3, we need to divide by 3, so 25 over 3. But it's not n is equal to this. In this case, it's n is bigger than this. Okay, n is bigger than this. Now, we don't have to work this out because 3 doesn't go into 25. However, there is another part to this question that says, solve the inequality, done, but find the least value of n. So n is bigger than 25 over 3. Now, using my 3 times table, how many times does 3 go into 25? 3 goes into 25, well, 3 goes into 24 8 times. So this is 8 and a third, okay, or 8.3. Therefore, if n is bigger than 8 and a third, okay, n could be 9, 10, 11, 12, anything bigger than 8 and a third, but the least value of n is 9. Very, very similar example below, okay? This time William has n marbles. Lois has 4 times as many marbles as William, but she has now lost 23, so 23 of those have disappeared. Lois still has more marbles than William, okay? Write down the inequality, job done. Now we solve it, okay? So again, to leave me up with a positive amount of n's, because there's 4n this side, I'm going to bring the u this way. That means the numbers I'm going to take this way. Minus 23 becomes 23. Don't change the sign. 4n, but you've come this way as minus n. This time it's 23 is bigger than 3. And sorry, 3n is bigger than 23. My apologies. 23 over 3 is less than n, or n is greater than that. 3 goes into 23, 7 and 2/3. Right, so bigger than 7, less than 8. That answer is there. So again, it's asking me what is the least number of marbles that William may have. Well, if he's got more than 7 and 2/3, he could have 8, 9, 10, blah, blah, blah. But the lowest number is 8. Okay. Moving on. We've got to be able to draw straight line graphs in inequality questions. So normally 3 inequalities, but we draw these 3 lines. So even though we're going to be shading these regions in, we're going to draw x plus y equals 6. Y equals x over 2 divided plus 3. X equals minus 2. Let's start with the easy one. Okay, x equals minus 2. I can draw that. Let me zoom it down. X equals minus 2. That's the straight line running up there. Okay, for the other two lines, I can't draw them until I draw a little table maybe and work out some x and corresponding y values. So let's start with the top one, where I'm going to draw x plus y equals 6. I've chosen three x values to be 0, 2 and 4. The reason I've chosen 0, 2 and 4 is because I've got 0, 2, 4, 6. I'm going with what I can see on the x-axis. Okay. When x is 0, 0 plus y equals 6. Alright, so what would I need to add to 0 to make 6? So y would be 6. 2 plus 4 equals 6. And 4 plus 2 equals 6. Let me put those 3 points on down here. Hopefully you can see that. So my 3 points are 0, 6, which is there. 2, 4, which is there. And 4, 2, which is there. Those 3 points are enough for me to be able to sketch this line. And then back up again, and we're going to do the same now for y equals x over 2 plus 3. Okay, if x is 0, that would leave me with y equals 0 divided by 2, which is 0, add 3. 2 divided by 2, which is 1, add 3. And 4 divided by 2, which is 2, add 3. Let's put those points on. Let's put it down again. Points are 0, 3, 2, 4, same as this line actually, so, and 4, 5, hard to see with these squares being as faint as they are. And again, connect that up. Now, we can see the region that's been made by these three lines. We've got this line, and this line. So the region that's going to be shaded here is that, okay? However, if you wanted to prove it, you could kind of look here and go, okay, what I need to be, the first line I've drawn, which is this one, I want to be less than that line underneath that line, which is this side of it. The second line I drew, which is this one, has got a greater than sign, so I want to be above that line, okay? And the last one again has got a greater than sign, so here's that line there, and I want to be above that line. So above that line, below that line, so the region that we need is in there. However, once you've made a triangle with your three lines, you can be pretty confident that just to shade in that triangle. Now, the reason I've gone through this one is because I didn't like these couple at the bottom. What is the greatest possible value of x such that all three conditions are met? Okay, so what is the biggest value of x that satisfies all those conditions, right? So I'm looking at this point here, which is x equals 2. Okay, this point here is below or on this line, right? Because again, if we go back here, my inequalities are not just less than or equal to, they're less than or equal to, greater than or equal to, greater than or equal to. The little line underneath means you can also be on the line, equal to the line, okay? So this point here is beneath that line or on it, above that line or on it, and to the right of that line, so it satisfies all three conditions, and that's fine. And then what is the greatest possible y value that satisfies all the conditions? Okay, I'm looking for the biggest y value in that region, which is the one up here where y equals 8. Okay, biggest x value in the region, biggest y value in the region, including on the lines. Unusual question, but hey. And this, okay, which I've done for you. The only interesting one here was y plus 2x equals 1. The other lines I knew how to draw without a little table for this one. And the other thing is, I thought it might be easier to draw. Instead of y plus 2x equals 1, I thought I'd move the plus 2x over, and it'd be easier to think of it as y equals 1 minus 2x. I certainly found that easier when putting 0, 1 and 2 x values in and working out corresponding y values, but that's what you should be aiming for. Again, hit pause if you want to see that. And finally for this video, you've seen these before, okay? trapezium rule questions, finding the area under here. So what we've got here is a little sort of almost triangle A, trapezium, 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 trapezium. I've labelled them A, B, C, D, E, and F. There's the kind of formula for finding the area of a trapezium. I'm not going into it because we did a lot of it in numeracy, but there's the area of A using base times height divided by 2. For the rest of them, all right, I'm using that kind of trapezium rule where, for example, for E, this would be A, this would be A plus B, half it, and times the height, which in all of these, the height is 1. Okay, my answer for that one was 73 in total. Same here, a few trapeziums with a triangle on the end, triangle F. I'm using the trapezium rule again to find the area under the curve. So I've split them up, found the area of all the different trapeziums, and I've got a total of 89 on this one. Okay, just check again they're happy. What you're doing, right, just final thing to say is you're almost looking at them side on as trapeziums like that, okay, where you've got a top, bottom, height, top, bottom, height, top, bottom, height, and so on, okay. We'll leave that there, and I'll see you in the next video.